Okay, so this is 11.6, surface area and volume of spheres. It's only two equations you really need to know for this section. It's pretty straightforward. First thing is get some definitions out the way. So we have a sphere, which is a three-dimensional round object. It says that a sphere is a set of all points in space equidistant from a given point called the center. So we have a center of the radius, or the center of the sphere, and if I was to draw a line from the center to out to every part of the sphere, the end point of the sphere, they would all be the same, just like a circle. So we would call that the radius of the sphere, and it's at the center. The segment passing through the center with endpoints on the sphere is called a diameter, just like a circle. So we go to one point of the sphere, go through the center, go to the other end point of the sphere. If we go to this point of the sphere, go through the end, through it, and to the other end, has to go through the center. We would call that the diameter of the sphere. We have a plane that goes through the center of the sphere. So if we had multiple planes cutting through the sphere, we'd have multiple sizes of circles at the intersection of the sphere and the plane. There is one particular spot where the plane intersects the sphere at the center, or you could think of it as the equator of the sphere, and that produces the largest circle, and we call that the great circle. And if you were to get the circumference of that great circle, or the circle at the center of the sphere, it would also be the circumference for the sphere. At the point where the great circle occurs at the equator, it cuts the sphere into two halves, and those two halves are called hemispheres. Hemi meaning half of a sphere. So the first equation is the surface area of the sphere, and the surface area of the sphere is very straightforward. It's 4 pi r squared. The units for a surface area again is squared, so it'll be feet squared, inches squared, meters squared, and you need the radius, and it's the radius from the center out to the end point of the sphere. So if I was to have, for number one, this they want the surface area of the sphere. They want your answers, two answers. They want it in terms of pi, and they want it rounded to the nearest square inch. They give you a diameter. They give you a diameter of 14. So we know that the radius is half of the diameter. So then the radius would be 7. We also know that the area that for the surface area of a sphere is 4 pi r squared. So we'll just substitute 7 for the radius, r. So the surface area would be 4 pi 7 squared, which is going to be 49. And then 49 times 4 is 196. So in terms of pi, it would be 196 pi inches squared. If I was to multiply the pi out, remember pi can be 3.14. You can use the pi symbol in your calculator. It can also be, and it's rounded to the nearest square inch, 616 inches squared. Alright, so they gave us the diameter of 14. We divided that by 2 to get the radius of 7. Then we plug that 7 in for the radius for the surface area equation, 4 pi r squared, and got 196 pi, or 616 inches. And remember that since it's the surface area, your units are squared. So this particular example, uh, it says that the Earth's equator is 24,902 miles long, and they want to know what the surface area is. So remember that the circumference of the great circle, or you could think of it as the equator, is the circumference for the sphere. So what you can do is that you can use your equation for the circumference, which in this case is 2 pi r, to find what the radius is. Uh, Circumference is 24,902. You divide both sides by 2 pi, and that gets you your radius. Once you get your radius, then you can plug it back in for r for the surface area equation, 4 pi r squared, and square the radius, multiply by pi, multiply by 4, and you get this huge number, which is, let's see, 197,387,117.5 meters squared. Okay, so we're going to use that type of example for got it number 2. They ask, well, what is the surface area of a melon with a circumference of 18 inches? So we know that the circumference is 18. We also know that circumference is equal to 2 pi r. So we're looking for r. So 18 is equal to 2 pi r. We're going to divide both sides by 2 pi. So then the radius is equal to 18 over 2 pi, or we can say 9 over pi. I'm going to keep it as a fraction for right now. So this is our radius. Radius is 9 over pi. Okay, so now that we have our radius is 9 over pi. You can turn this into a decimal if you want, but I'd rather keep it as a fraction. Then I can plug it into my other equation for the surface area. I know that the surface area is equal to 4 pi r squared. So the way that I'll do that is substitute 9 over pi for the radius. And let's do a little manipulation. So I'm going to put the pi to the back. And I'll have 4, I call it 4 over 1, times, when you square a fraction, you can actually square the top and you can actually square the bottom. So 9 squared is 81. And then pi squared is pi squared. And then we have this pi in the back. So this pi and one of the extra pi's down here cancels out. And then I have 4 times 81, which is 324. So then I get 324 over pi. That's our surface area, and they want this to the nearest 10 square meters. So if I was to divide that by pi, I get 103. But they want that to the nearest 10th place, so, or tens place, so it's going to be 100 square inches. Now you could have done this also with decimals and did 9 over pi, and it would have been like 2.864788967 and square that and gotten the same answer. But I think it's a little bit, when you're dealing with pi's like this, I think it's a little bit easier if you sort of did it with fractions, with divide and ultimately dividing and multiplying by pi last when you have a pi in the numerator and denominator. But it is totally up to you if you want to use decimal or fractions. I recommend fractions though. It's better in the long term for your mathematical career to use fractions a lot. Okay, so volume of a sphere, they have a whole spiel about where it came from and how they got to the equation. I'm not going to do that. I'm just going to give you the equation, and here it is. The volume of a sphere is equal to 4/3 pi times the radius, and the radius is cubed. The radius is cubed, not squared, cubed. And so that means that your units are also going to be cubed since we're dealing with volume. Feet cubed, inches cubed, meters cubed. They all are going to be cubed. So, and got it number 3. It says that we have a sphere with a diameter of 60. So if the diameter is 60, I know that the radius is half of that, so the radius is 30. So all I would have to do is I'm going to plug in 30 for the radius. So the volume would be 4/3 30 cubed times pi. They want the volume to the nearest cubic inch, so I'm still going to do one as pi and then one as the cubic inch. So that's going to be 4/3 30 to the third power is a big number. 27,000 times pi. Multiply that by 4/3. And I get 36,000 pi. If I multiply that by pi, and they want me to round it to the nearest cubic inch, I get this other big number. So I'll get 113,097 cubic inches, or inches cubed. So in this case, they gave me a diameter. I divided it by 2 to get the radius, and then plugged it into my equation, which is 4/3 pi r cubed, and plugged in 30 for the radius. The cube of 30 is 27,000. Multiply that by 4/3, and I got 36,000 pi. If I was to multiply it by pi, which is 3.14, or the pi symbol, I recommend using the pi symbol, it'll turn out to be 113,097, rounded to the nearest cubic inch. Alright, so this last example, they want you to find what the surface area is if you're given the volume. So they give you, for this example, step 1, they give you the volume, which is 5,000. We know that the volume is equal to 4/3 pi r cubed. So they plug in 5,000 for the volume, V. They plug in, they have the 4/3 pi r cubed here. I'm going to multiply both sides by the reciprocal of 4/3, which is 3/4. So remember that the reciprocal, if we have 4/3, the reciprocal is where the denominator is in the numerator and the numerator is in the denominator. So they've switched sides, right? 3 goes up here, the 4 goes down here. And when I multiply it, it's going to be 12/12 or 1. So the reciprocal is when you multiply two fractions such that the answer is always 1, basically canceling out the other fraction. What I do on one side, I do to the other. So if I multiply the right side by 3/4, I'm going to multiply the left hand side by 3/4. So that's where the 3/4 came from. Then they divided both sides by pi, which is why there's a pi in the denominator and no pi here. So the radius cubed is equal to 5,000 times 3/4, or 5,000 times 3 over 4 pi. In order to get the radius by itself, I'm going to do the opposite of cubing, which is to cube root. Notice that there's a 3 outside the radical, which means that I'm cube rooting, not square rooting, cube rooting. So I'll use 2 as an example. 2 squared. This is about the difference between cube rooting and square rooting. So if I had 2 squared, I know that 2 squared is 2 times 2, or 4. If I was to go in reverse and say what's the square root, what they don't really tell you is that there's actually a 2 here, but we don't write it for square roots. That means that it's going to be 2 times 2, and that's the number that I'm multiplying twice to get to 4, or 2. So that would be my answer. The square root of 4 is 2. This is something that you guys already know. When we talk about cube rooting, it's the opposite operation of cubing. So if I have 2/3, or 2 to the third power, it would be 2 times 2 times 2. I'm multiplying it 3 times, or it would be 8. So when I talk about the cube root of 8, it's the number that I multiply 3 times to get to 8. So again, 2 times 2 times 2. So the cube root of 8 is 2. Same thing with this. I'm trying to find out the number that I multiply 3 times in order to get this number, which is 5,000 times 3 over 4 pi. And that number on the example is 10.6078448. That's my radius. Then I'm going to square that number. Then I'm going to multiply it times 4 and pi to get the surface area, which is rounded to the nearest square meters, is 1,414. So here they give me the volume. Volume is equal to 4,200. I know that the volume of a sphere is equal to 4/3 pi r cubed. So I'm going to have 4,200 equal to 4/3 pi r cubed. Again, I'm going to multiply both sides by 3 over 4. These guys cancel. I'm going to divide both sides by pi. Those guys cancel on the right hand side, so now I have 4,200 times 3 over 4 pi equal to the radius cubed. But remember, I'm going to cube root this to get r by itself. So I'm cube rooting. So then my radius is equal to, I'll multiply that 3 out. No, I can divide that. Let's do this. So it's going to be 3150 over pi cube root is equal to r. So that's our radius. Lovely. Once we find our radius, we can substitute that into our surface area equation. If you want to know what the number is, it's going to be about 10.00891253. So that's what the number is. if you were to cube root it. I'm not going to cube root it. I'm going to keep it as is. So surface area is 4 pi r squared. We know what pi is, so it's going to be equal to 4 times pi times 10.0089125 squared. And I get, they want it rounded to the nearest tenth. And I get 1,259 feet squared. Oh, they want to turn to the nearest tenth. My fault. 58.9 feet squared. My mistake. Okay. So that's this section. 11.6. Surface area and volume of spheres. Hope you guys have a great day.